So in this problem we have been given that is x square is equals to 2 raised to the power x, and then we have to find value of x. So how will you solve this problem? Generally this kind of problem we can solve by taking log. So let us take log both sides of this expression. So we can say ln is log x square is equals to ln 2 raised to the power x. Now in this case basically ln means on the base of e. So if I am writing ln e, that is ln x square, this means ln on the base of e, log of x square on the base of e. So this is simply as ln x square. So I am using this convention or notation in this problem. Now you have rules of logarithm, that is if you have ln a raised to the power m, then you can write m times ln a. So basically power comes as a product. So this is the rule we will use. So if I use this rule, I can write 2 times ln x is equals to, this will become x times ln 2. Now let us take x term one side and constant term another side. So I will have ln x divided by x is equals to, so this is ln. So let me write a small l. So this is ln x divided by x is equals to ln 2 divided by 2. So if we can solve this expression, then we can basically find the value of x. So now if you closely look this equation, this side you have ln x by x kind of thing, both sides. So x is equals to 2. So here I have x equals to 2. That clearly satisfies this equation. So x is equals to 2 is one solution. Now this is the only solution or we have some more solution? That is the question. So let us try to see or investigate further. So I have ln x by x. What I will do is I will multiply right hand side in the numerator by 2 and in the denominator also by 2. So now this will become ln 2 raised to the power 2. I am using the same rule that the product becomes the exponent, and this divided by 2 into 2 4, which is equals to 2 square. So I can write ln x by x is equals to ln 4 by 4. So now if you see the left hand side and right hand side, in this case x and 4, here also x and 4, that is ln x by x, that is ln 4 by 4. So 4 is the solution of this equation. So x is equals to 4 is another solution. So we have found two solutions. One is x is equals to 2, another is x is equals to 4. Now the question is, do we have any other solution? Now to find that whether it will have only two solutions or more solution, we need to investigate the function. We need to plot the function. And generally in any calculus book you will find steps to plot a function. So let us discuss that. So what is the function we have? In our case function is log x divided by x. Now to investigate this function or plot this function, the first step is to find where the function has critical point. That is point where function has minimum or maximum. So we can find critical point. So the first step is to find critical points. Now how we find critical points? So what we do is we differentiate this function. This is a part of calculus, and then equate equals to 0. So now I will use one result, that is, if you have a differentiation of u by v, so if you want to differentiate u by v, then what you have to do is, first you have to differentiate u, leave v, minus leave u, differentiate v, and then you will have v square. So this result I will use, that differentiation of a function in the form of u by v is calculated using this formula. So now let us see what is function I have. I have fx is equals to ln x divided by x. So if I differentiate this with respect to x, so I can write f dash x is equals to, as I said, leave the denominator and then take differentiation of ln x, that is numerator. Ln x is 1 by x minus, this time leave the numerator, and differentiation of denominator, that is differentiation of x is 1 divided by denominator square, that is x square. Now equate it to 0. So we will have f dash x is equals to 1 minus ln x, and this divided by x square. So 1 minus ln x divided by x square is equals to 0. Now x square, I am assuming that x is not equals to 0. So this means ln x is equals to 1. So ln x is equals to 1, and this is on the base of e. So this means x is equals to e raised to the power 1, that x is equals to e. So critical point occurs at x is equals to 1. So the first step, at the end of the first step, we know the critical point. So critical point is at x equals to e. Now we need to find whether this is a maxima or minima. So at x equals to e, you will have maxima or minima. So that is the second step. So in step 2, you have to find f double dash x. And f double dash x is less than 0, then you will have a maxima. And if double dash x is greater than 0 at critical point, in this case critical point is x equals to e, then you will have minima. So let us find f double dash x. We already know f dash x, which is equals to 1 minus ln x divided by x square. Now I have to differentiate once again. So as I know, I will use the result, that is leave the denominator and differentiate the numerator. So differentiation of 1 is 0 minus differentiation of ln x is 1 by x minus leave the numerator 1 minus ln x and differentiate the denominator. So x square differentiation is 2x divided by a square of denominator, that is x square. So now we will have if double dash x is equals to, so this will be x minus 1 minus ln x and multiplied by 2x. So this will becomes 2x plus 2x times ln x divided by x4. Now let us find the value of this term at critical point. So what is the critical point? X is equals to e is the critical point. So what is the value of f double dash x at critical point, that is x equals to e? So we will have e minus 2e plus 2e ln e, and this divided by e4. So I made a mistake here. So this is minus e, this is minus x squared. So if you see this term, x squared times minus 1 by x. So this will be minus x. So there is a mistake. So this is minus x and this will be minus e. So minus e and minus 2e. So I will have this value minus 3e. And this will be what? So 2e times ln e, and ln e is 1. So this is plus 2e divided by e4. So this is minus E divided by E4. So this is a negative quantity because you have a negative sign here. So this is a negative quantity. So this means at x equals to E, what we will have? We will have a maxima. So at x equals to E, we will have a maxima. So maximum will occur at x equals to E. Now let us try to plot this function. That is a step 3. So in a step 3, we can basically plot this function. So we have, so this is my y-axis and this is my x-axis. So this side, I don't need to have too long. So this is my x-axis. So this is not vertical. So now this is the coordinate axis. Now we want to plot this function, and the function is fx is equals to ln x divided by x. We know that x equals to E. So this is my x-axis and this is fx. So at x equals to E, we have maxima. And what will be the value of maxima? So ln E, that is 1 divided by E. So at x equals to E, so this point is x is equals to E, and the maximum value we will have, that is 1 by E. Now if you see this function fx is equals to ln x by x, what will happen if x goes to infinity? So if x goes to infinity, we have to take the limit, that is limit x tends to infinity. What is the value of ln x by x? So this is a form of infinity by infinity. So I can use L'Hospital rule. So this is, I can differentiate in the top and I can differentiate in the bottom, that is numerator and denominator. So this will be 1 by x, and differentiation of x is simply 1. So this is 1 by x. Now if x tends to infinity, this function basically will tend to 0. So this will be 0. So now I know that when x will tend to infinity, this function fx will tend to 0. So from where this result I got from limit. That is, I took the limit of ln x when x tends to infinity. But now this is a infinity by infinity form, so I have to use L'Hospital rule. Then I can differentiate in the numerator and I can differentiate in the denominator. This is simply 1 by x. Then if you x tends to infinity, then 1 by x will tend to 0. So fx will tend to 0. What about x negative number? Now if you remember, log function is not defined for negative number. So this means x cannot be negative. X is always greater than 0 because this function, log function, is only defined for positive number. So domain is x is greater than 0. Now what will happen when x tends to 0? So now when x tends to 0, that is very close to 0, now fx, which is equals to ln x divided by x, will tend to infinity, basically minus infinity, because log of any number between 0 to 1 is negative. So log x will be negative. So if x lies between 0 to 1, very close to 0, log x will be negative, and this number x is very small number. So you are dividing a negative number with a very small number, then this will tend to minus infinity. So now using this, we can basically plot this graph. So when x is negative, so let us say this point is 1 and log 1 is 0, so it will basically pass through this point because log 1 is 0. So if you see, what will be the value of ln x by x at x equals to 1? So let us find this value also. So f1 will be ln 1 divided by 1, but log 1 is 0, so 0 by 1 is equals to 0. So this means this will pass through this point, that is this point, that is x is equals to 1. So this point is x equals to 1. And between 0 and 1, this will tend to minus infinity. So this is something like this. And then when x tends to infinity, it is going to 0, something like this. So this is the function, because at this point this is a maximum value. So this function is going like this, and at this point this has a maximum value, and then this is decreasing. So this is your fx function. Now the right hand side, if you remember the original problem we have, that is ln x by x is equals to ln 2 by 2. So we have plotted the graph for this function, that is fx is equals to ln x by x. So we have plotted the graph for fx, which is equals to ln x by x. Now let us consider gx, that is ln 2 by 2. We can also plot a graph for gx. ln 2 by 2 will be a number, it's a constant number. And the value of this number is less than 1 by e. You can check yourself. So this is ln 2 by 2. This value is less than 1 by e, because e is 2.7. So this is 1.27. So this is 1 by e, which is equals to 1 by 2.7. And if you take log ln 2 by 2 and you calculate, then you will find this value is less than 1 by 2.7. So if you plot a graph for gx, so gx will be something like this. Gx is constant, it's a one number, so constant. So this is a function of gx. So now what are the points where fx is equals to gx? So this is the point, that is fx is equals to gx. This is another point where you have fx is equals to gx. Basically, these are the two solutions that we earlier found. So this corresponds to x is equals to 2. And this corresponds to x is equals to 4. So this corresponds to x is equals to 4, and this corresponds to x is equals to 2. And this point is x is equals to e. So this point is x is equals to e, where you have maxima. So this is maximum. Now I will illustrate this using a graph plotter. So let us plot fx, which is equals to ln x by x. So ln x, and this divided by x. So now you see, this is the function of ln x by x. You can clearly see that in this case, this is the point, that is 1, x equals to 1, and this point somewhere you have the maximum, so that is 1 by e, x equals to 1 by e. Now let us plot gx, that is the second function we have, that is ln 2 by 2. So this is ln 2, and this divided by 2. So you can see the value of ln 2 by 2 is 0.34. So this function we have, that is by equals to, so I can write by equals to this function. So this is, I can rewrite. So this is by is equals to ln 2, basically ln 2 divided by 2. So you see, this is the function that is in the red. So that is gx function we have. Now you can basically, you can zoom this. So if I zoom this, then you can clearly see that at this point, so there is a point where it is intersecting. So this point, I need to further zoom. So you see, these two functions are basically crossing at this point, somewhere here, so that is 4. So this point is 4. So you see, in this case, this point is somewhere crossing here, that is x equals to 4. That is one route. Now another route we will have, that is at x equals to near to this point, x equals to 2. So that is, if I zoom it here, you can see clearly. So this is this point. I am further zooming. So now you can clearly see this point is basically x is equals to 2. So in this case, this is two solution. We cannot have any further solution. There is only two solution. because these two graphs are only intersecting at 2 points. It will not intersect at any further points. So in this case, we have two solutions. So that's why here we have said we will have two solutions, and we found using graphical method we also verified this. So I hope you enjoyed this video, and if you enjoy, please share with your friends, and I will see you in the next video. Thank you.